dear students. Hope all you are fine. Alhamdulillah, by the grace of Almighty Allah, I'm also fine. So, here I'm beginning with a new science class, and obviously it is a revision class. We have already done the revision class of chapter 1, chapter 6. On the proceeding, we will do chapter 7 today, the earth and gravitation. Okay, so the previous videos we have discussed a lot about the full lesson. So here today I want to show some videos on that lesson to see all the phenomena, what about the gravitation, what about the gravity, then acceleration due to gravity, and then the different value of g, why it is different, and then what is mass, what is weight, everything. Okay, so gradually one after one we will see video. First of all, we will see the video of Newton's law. That means you know what is happening in the universe. Every object attracts each other, isn't it? This attraction force is proportional to the mass, product of the mass their object, and inversely proportional to the square of their distance. Okay, so you have learned this one. I hope you will be more clear by watching this video.
Gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? Or do both move towards each other? It's actually simple logic. This is the earth, and say this minuscule object is an apple. Based on what we learnt about the gravitation,
their distance. Okay, so you have learned this one. I hope you will be more clear by watching this video.
gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? Or do both move towards each other? It's actually simple logic. This is the earth, and say this minuscule object is an apple. Based on what we learnt about the gravitational force, both apply an equal force to attract the other object towards itself. So if the forces are equal, which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So the acceleration will equal force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser. As the mass of the earth is much more than the mass of the apple, it is the apple that accelerates towards the earth and not the other way around. Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept. And this simple concept is called the universal law of gravitation. Say there are two objects A and B separated by a distance d. The distance between the centers is considered the distance between the two objects and not this distance. Assume that the mass of object A is m1 and that of object B is m2. As object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So if the mass of any of the objects increases, the gravitational force will have more magnitude. And more the distance between the two objects, the lesser will be the gravitational force. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equals G times m1 times m2 over d squared. G here is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equals F times d squared over m1 times m2.
I hope you have enjoyed the video. So now we will go for the next topic, gravity. Gravity. What is gravity? Gravity is one type of gravitation. So what we can say that any attraction force between Earth and any other object. Earth and any other object. That object can be me, can be this one, can be anything in the world. Okay. So attraction force between Earth and any other object due to Earth on it is called gravity. So after gravity, we must know acceleration due to gravity, and video is all about acceleration due to gravity, g changes place to place, but the rate of free falling object or the value of free falling object is always equal, that is 9.8. Next one is mass and weight. You know all about mass and weight, is it? So in case of mass and weight also I want to show a video. Then today's classes mostly I have organized with the videos because previous classes was the regular class and all those classes we have discussed a lot. So those discussions will be fulfilled by the practical observation. So that's why I have integrated lots of video in today's class. I hope you will enjoy this video also.
Most of us think that mass and weight are pretty much the same thing. Are they? No, they're not. There's a very simple way to understand the difference. Mass is simply the amount of matter that's present in the object. Now consider two situations. One in which an object is on the earth and second in which the same object is on the moon. Will the mass of the object be different in these cases? To answer this question, we ask ourselves another simple question. Will the amount of matter present in the object be different in these cases? Absolutely not. The matter in the object is not changing at all, which is why the mass will be the same in each of the cases. The mass of an object remains constant no matter where it is placed. The standard metric unit of mass is the kilogram. Another concept we'd learnt about an object's mass was that it is a measure of its inertia. Greater the mass of an object, greater will be its inertia. Inertia is nothing but the tendency of an object to resist change in its state of motion. So now we have an idea about what mass is. But what's weight then? How do we understand the weight of an object? Mass is nothing but the measure of how much matter an object has. Weight is a measure of how strongly gravity pulls on that matter. It's the measurement of the gravitational pull of an object. Let's understand this using a simple example. Say there are two places, place A and place B, and there's an object of mass m. In place A, the pull of gravity is x units, and in place B, the pull of gravity is 2x units. Clearly, the pull of gravity is stronger at place B. Now understand this well. The mass of the object will be m at both the places, but the weight of the object will be greater at place B because the pull of gravity is stronger. As the gravity is twice as bigger, the weight of the object will be twice as much at place B as compared to place A. So the weight of an object is a measurement of gravitational force acting on it. How can we understand weight using a formula? We know the Newton's second law of motion, which says that the force acting on an object is the product of its mass and acceleration. When it's acceleration due to gravity, we can replace A with a lowercase g. This force due to gravity is nothing but the weight of the object. So if we consider the weight of an object to be uppercase W, we can rewrite this equation as W equals m times g. So the weight of an object is the product of its mass and acceleration due to gravity. What will be the SI unit of weight? Can you guess? It'll be the same as that of force, Newton. As the value of g at a particular place is constant, we can also say that the weight of the object is directly proportional to its mass. Here's the main takeaway from this video. The mass of an object remains constant everywhere, whereas its weight depends on the gravitational force at the location.
Okay, now we will learn some creative question, that is sample creative question from chapter 7. So here I will try to discuss 3 creative questions, and third number sample creative question will be learned and write for you. Okay, so first one, sample creative question number 1. So what is the question, my students? You see, a material of 100 kg mass pushes 9.8 meter per second square. Acceleration due to gravity. This material is taken to the moon and its weight changes. First of all, you have to understand the spin. Okay, so here what is given? It is given that its mass is given, 100 kg. And its acceleration due to also gravity is given 9.8. Which one? The standard one. Now, we will find out the weight by this. We can find out the weight by this. Why? Because we know that it equals to mg and both are given here. And then it is taken to moon. So what will happen? We know in the moon it is, we have to multiply 1 by 6 with mg. Is it? So obviously it will change. So let's see sample question number 1 in our question. What is gravitation? Gravitational force between any 2 objects in the universe is called gravitation. Okay. 2 number, what do you mean by the value of acceleration due to gravity is 9.8 feet? B number. So A, you will write only the definition. Next point, first part is knowledge base part. You know 9.832 is the value of G at polar region. Okay. So what we will write? The value of small g is 9.832 meter per second square is at polar region. Got it? This is the knowledge base part, and then you will explain in second para. In second para, you will explain. What you will explain? That what is acceleration due to gravity and why? What is the value of g? Standard value 9.8, and why it changes? Because of the distance from the Earth center. The value of g changes, and at the polar region, the distance from the center is less. That's why the value of g is more. Here, this is the discussion part of this question. Next one, determine the weight of the earth. Determine the weight of the earth in the mentioned stem. I have told it at the beginning. C number. What is given? C number, what is given in the question? Given, therefore W equals to mg. So you will put the value of m 100 into 9.832, and the unit of weight is Newton. So this one you multiply, what will happen? 983.2 Newton. It is the answer. Got it? Why does the weight of the thing mentioned in the stem vary on the moon? Why does the weight of the thing mentioned in the stem vary on moon? So first of all, in the sea, you got the weight of the object in the earth's surface. Now we will find out the weight of the object on the moon. And in case of moon, on the moon, W equals to 1 by 6 mg. This formula you have to use. Find out the weight on the moon. And then you got from C the weight of the object on the earth's surface. Is it? So that one also you will write. Okay. That means find it out. Then from C you got what you got? The value on the weight of the material on the earth's surface is 983.2 Newton. Then what is the change? Here you will find out the change by subtracting these two. And you will get the change. So why changes? Why changes? You have analyzed that it has changed. You have shown mathematically that it has changed. Now you have to discuss a bit. What you will write as discussion? As because of the size of the moon compared to the earth is very less, and it is compared 1 by 6 to the earth. Okay, that means moon is one portion. If we divided our earth in 6 parts, one portion will be the moon. So it is very small than the earth. Okay, so that is why the weight of the material vary on the moon. I hope all of you understand. My dear students, now we will go for sample predictive question number 2. So what is the sample predictive question number 2? There is two objects of mass 5 kg and 10 kg are allowed to fall from roof of a high-rise building on the surface of the earth. One is 5 kg and another is 10 kg. Okay, distance between the two objects is centimeter. Now, I understand. Draw the step. It will make you easy to understand. Two number. So one object. Suppose this object name is A, and their distance is suppose this object is B, one is 5 kg, another one is 10 kg, and their distance is what? Centimeter. One thing you must know, if anything is written in gram, you have to convert it in kg. If anything is written in centimeter, you have to convert it in meter. Okay. So actually this is the step, this is the phenomenon, and both are falling from a high-rise building. Okay. Now, A number question. What is gravity? Answer me. Yes. What is gravity? Action force between the earth and any other object due to earth is called gravity. Only this definition, no other thing. And the definition should be complete one, not incomplete. Like if you write action force between earth and any other object is called gravity, I will not accept. Why? Because the attraction force is due to earth. You have to mention this one. So attraction force between earth and any other object due to earth on it is called gravity. Clear? Next one. Why does the passenger of a lift feel himself lighter than the lift goes downward? That means when the leaf, suppose this is a leaf. When the leaf is going downward, the person feels lighter. Why? Why? One thing, first, before answering this question, I want to discuss one thing. That what do you feel when you just go down with the stairs? It's like you're flying, isn't it? Because you feel less weight. But when you move upward, that time you're exhausted. Why? Because you feel more weight. So one thing you must know, as we are going down from the upper surface to the down, that time what is happening? Suppose this is the earth surface and it is going up. What is happening? Distance increasing? Yes. So the earth center is pulling you down. Okay, that's why you feel more weight. Suppose if I want to go anywhere, someone is pulling me from back. So what will happen? I will feel more weight. No, I cannot move like this. So the same thing happens when you going down. That time you are going towards the earth center, isn't it? So here, as your distance is decreasing, you feel lighter, because as you are going towards the earth center, your attraction increases. That's why you feel lighter. Got it? So the answer, what we will write in case of B, the knowledge base part, we will write because B number, we go towards the gravity. This is the knowledge base part, and then we will explain in details. Another thing you have to keep in mind, that is there is a law of Newton for force, that every action has equal reaction. So while we are going down, then we are giving more force to the opposite force. Okay, and that's why what is happening? Here we are giving more force to the opposite force. That's why we are also feeling lighter. So these two things, one is our gravity, going towards the gravity, and the point is the force law, that we are giving more force to the opposite force. Here, I was. Next one, show the attraction force between the object. F equals to 200 G Newton. Okay, my dear students, C number, show the attraction force between two objects is F equals to 200 G Newton. So here, what are the information given? You know that one, that I have given this one name A, this one B. So following this stem, we will write like here, A is, suppose A is M1, B is M2. M1 is 5 kg, M2 is 10 kg. Fine. And B is, so as I say, and you know that one, we have to convert it in meter. So convert it in meter, then we know the formula from Newton's gravitational law. We have to write this one. What do we write? Gravitational force F equals to gravitational force F equals to G M1 M2 by D square. Here, so here F equals to G. We will put the value of M1, M2, and the value of G. So this will be like this. I have given you a graph how to do this one, and the value will come 200 G. You will not input the value of G. No need, because it is not axial. So F equals to 200 G, that is gravitational constant. Okay. that is proved or showed. You may write here showed. It is also nice. Next one, if two objects are taken on the Earth's surface of the moon, whether the sum total of weight of two objects will be different. Again, see, if the two objects are taken on the surface of the moon, whether the sum total of weight of two objects will be different. Analyze mathematically. This is very simple and easy math, my dear students. You have to do your own. First of all, you have to find out the weight on the Earth's surface, and then you have to find out the weight on the moon surface. There is two steps. D number. First, on the what you have to do? It is said sum total of weight of two objects. That means separately you have to find out the weight of two objects. So, okay, my dear students, for object A, what will be the weight? Object A equals to what? A mass equals to 5 kg. Is it? And value G is 9.8 meter per second square. So here W equals to what? mg 5 into 9.8 Newton. Got it? So you have to find out the weight of B also. M equals to 10 kg. Now we have to find out the total sum. That means you have to add 49 plus 98. The total weight 49 plus 98 Newton equals to how much? 147 Newton. The same procedure you have to do for on the moon surface. Okay, and then whatever the value you will get on the moon surface, you will subtract. I'm repeating, the value on the Earth's surface and from the value on the moon surface, both you will subtract. And what is the difference you will get? That's it. This is the end of sample credit question number 2. Now, my dear students, this is sample credit question number 3. See, the mass of the two objects P and Q are 50 kg and 30 kg. So the distance between them is 5 meters. Everything is very simple. That means P and this is Q. Q is 30 kg and P is 50 kg. Okay, and distance between them G equals to how much? 5 meters. Each and every time you must draw, if this type of system you get from in the question, then you must draw this concept. Okay, it will help to understand clearly. See, what is called weight? What is called weight? It is a force, right? So, a number, the force by which Earth attack any object to its center is called its weight. Got it? Okay, B number, what do you mean by the acceleration due to gravity? So, what is the acceleration due to gravity? First of all, you will write the definition. And what is the definition? The rate at which the velocity of a free falling object changes due to the force of gravity is called acceleration due to gravity. This definition you will write. Next para, that will in discussion para. First of all, write definition, and second para you will write a big discussion like what is acceleration, what is velocity, all this, and by this acceleration due to gravity is done. And then you will write the value of what is it expressed by. Acceleration will be expressed by small g. And what is the value of it? That is standard value. And on it, that's it. You could write this information, you will get 2 out of 2. Then C number, if G, the value of G is given. Okay. Find out the gravitational force of the objects, given objects. That means what are the given objects? P and Q. So here all the value is given. M1 into D and G. All the informations are given. That means we know F equals to G M1 M2 by D square. Input all the value, calculate it, you will get the result. Got it? D number, what type of changes of force is occurred with the respect of the previous force of the mass of the P and Q object are half and the distance between them is double. Analyze mathematically. So, I will not do this one, my dear students. In the previous video recorded class, I have explained very nicely. So, take the help from there and do yourself. Got it? This sample credit question number 3 is your learn plus writing homework. Okay, so homework number is what? Homework number 14. And what is homework? Sample credit question 03. Sample credit question number 3. Today's 3 number sample credit question. This one. Got it? Take a screenshot, write in your copy, and then do this whole credit question. And my dear students, you will also practice the given other 2 credit questions, those I have discussed. Clear? So this is all about revision of chapter 7. I hope all you did understand and must practice, because chapter 7 is mostly mathematical terms, and here mathematical things you have to do. So if you are not practicing, then you will be in problem. It is all about physics. Okay. So I hope you will practice. If you understand properly, then you will get a good result easily. You don't run for the result. So my dear students, that's all about today's class. Thank you all for being with me and for enjoying the class, and also for your full attention. Today, Allah Hafiz, all of you. Take care.